Hi, I'm Dr. Incognito. In this video, we're going to discuss critical numbers. So first, what is a critical number? A critical number for a function is a value which is in the domain of the function such that one of two things happens. Either one, f prime of that number is equal to 0, so that the curve y equals f of x has a horizontal tangent line, or f prime of x0 is undefined. So that f is not differentiable at x0. Maybe the function has a corner point at x equals x0. Or maybe the function has the curve has a vertical tangent line at x equals x0. So let's look at some examples. Let's find the critical numbers of the function f of x equals x cubed plus 6x squared minus 14. Let's find the critical numbers. So this function is a polynomial function. It's defined for all x. So in other words, the domain of this function is all real numbers. And now let's consider the derivative. F prime of x is 3x squared plus 12x, which exists or is defined. This is defined for all x. And I say that because then there are no critical numbers of this second type where the derivative is undefined. So let's solve the equation f prime equals 0. Solve this for x. And if there are any solutions, then those will be the critical numbers of the function. So 3x squared plus 12x equals 0. That gives us, if we factor out 3x times x minus 4 is equal to 0. So either 3x is equal to 0 or x plus 4 is equal to 0. In the first case, x is equal to 0, and in the second case, x is equal to negative 4. So this function has two critical numbers. X equals 0 is a critical number, and x equals negative 4 is a critical number for this cubic polynomial. In both of these places, the curve has a horizontal tangent line. The derivative is 0, corresponds graphically to a horizontal tangent line. If we were to draw the graph of this curve, it would look something like this. This is a little bit off. That should be on the axis there. When x is 0, we have a horizontal tangent line, and when x is negative 4. Oh, Christ. I'm drawing this completely wrong. I was doing 4. Should have done negative 4. It looks something like this when x is negative 4, and then when x is, oh my God, okay. So when x is negative 4, we have that point there, and when x is 0, we have this point here. Those are the critical numbers, negative 4 and 0. Here's 0 on the x-axis. At negative 4 and 0, the curve has a horizontal tangent line. For the next example, we will consider the function f of x equals the cube root of x times x minus 2. This function is also defined for all real numbers. The domain of f is minus infinity to infinity. You can take the cube root of any number, positive, negative, 0. So there's no problems with cube roots. So what is the derivative of this function? In order to calculate the derivative, we should probably rewrite this function as x to the 4/3 minus 2 times x to the 1/3. So what I've done there is I've said the cube root of x is x to the power 1/3, and then distributing that, I get this. When you multiply x to the 1/3 times x to the 1, you add the powers, and so you get x to the 4/3. Now let's calculate f prime. That's 4/3 x to the 1/3 minus 2/3 x to the negative 2/3. Subtracting 1 from the powers, 4/3 minus 1 is 1/3, and 1/3 minus 1 is negative 2/3. So we have this. And now we have to notice that f prime of 0 is undefined. And that's because if you plug 0 into a negative power, 0 to the power negative 2/3 would mean 1 over 0 to the 2/3, and that gets a division by 0 error. So this is undefined. So f prime of 0 is undefined. F of 0 is defined. F of 0 is 0 times negative 2, which is 0. So f of 0 is defined, but f prime of 0 is undefined, and that means that x equals 0 is a critical number. This function has another critical number as well, because critical numbers come in two varieties. The other variety is where the derivative equals 0. So if we take f prime of x, instead of equal to 0, and solve for x, we get the following. 4/3 x to the 1/3 minus 2/3 x to the negative 1/3 equals 0. Sorry, x to the negative 2/3 equals 0. The best way to solve this equation is to multiply both sides through by x to the power 2/3. Multiply both sides by x to the 2/3. Then what we get is 4/3 x, we're distributing here, minus, the point here is x to the 2/3 times x to the minus 2/3 is 1. So we get simply minus 2/3, and that equals 0. So multiplying by 3, we see 4x minus 2 is equal to 0. X is 2 over 4, which is a half. So there's a critical number where we have a horizontal tangent line at x equals a half. And at the other critical number, x equals 0, where f prime was undefined, the curve itself, if you were to make the graph of this function, it has a vertical tangent line when x is equal to 0. One last example. If we consider the function f of x equals the absolute value of x, this is also defined for all real numbers. F prime of 0 is undefined. Let's look at the graph of the absolute value function. It looks like a V. So here at x equals 0, it has a corner point. And so f prime of 0 is undefined. The absolute value of x is not differentiable at x equals 0. And therefore, x equals 0 is a critical number. There are no other critical numbers for this function. F prime is never 0. Along here, f prime is 1, the slope is 1. And along here, f prime is negative 1. So it's never 0. It is undefined when x is equal to 0. F prime is undefined. So at that corner point, we have a critical number. Okay, so there's a little look at critical numbers. Thank you for watching.